it is. Okay. So me, Julia, and Kaylin are all here with the TA, Anna. And we're not sure where Russell is. But so we're just going to go through the questions and let us know, Anna, if we have any that are wrong so far.
Okay, sounds good.
All right, so for question 3, the third option, just P, is the true population proportion. Question 4, the requirements are satisfied because if you plug in n times p hat, you get 10, and it has to be greater than or equal to 10 to be satisfied. And then question 5, we thought it was also satisfied because of the central limit theorem. Is that correct, Anna? Meaning that the sample size has to be high enough?
Will you read the question to me? Sorry, I only have the answers in front of me. Will you read that question one more time?
Okay, she only has the answers. So the question is, the requirements for conducting a hypothesis test are satisfied. And they give us n equals 100, p equals 0.25, and p hat equals 0.1.
Okay, yeah, and those would be true because you would just plug them in like you would for the question before it.
Right.
Mm-hmm, yeah.
So for that one, which part would we exactly plug in to be able to confirm that we can conduct a hypothesis?
It's the same. So it's the n times p is greater than or equal to 10.
Instead of n times p hat.
Yes. Let me double check on that. Oh, sorry, 1 second. I have all the. No, sorry, it's still p hat. So it's n times p hat. So you would just have to find p hat. Do they give you an x and an n on that one?
They give us p hat.
Oh, they give you p hat. So yeah, you would still do p hat. Sorry.
Okay. So for question 6, to find p hat, as we know, you do x over n. So x is 45, n is 60. We all get 0.750. All right, question 7, margin of error. And we know from the 95% confidence interval that 1.96 is the z-score. So you take that multiplied by the square root of 0.750 times 1 minus 0.750, all over 60.
Do you guys also want an easier margin of error formula?
Yeah, that would be great.
Okay, so you can take the confidence interval that you find on the Excel sheets.
Just give us an easier formula. Okay, wait, hold on. Let me write it down.
Okay.
Yeah. Using the Excel sheet, I guess. So, okay. So you take the what?
So you just take on the Excel sheet, there'll be like a confidence interval and it'll have like a lower number and an upper number, like the lower bound and the upper bound, right?
Okay. Yeah. So lower and upper bound.
So you just take the upper bound minus the lower bound and divide all that by 2.
Oh, yeah. We've done that in the past. Julia, remember? Upper minus the lower.
Okay. Because a lot of people didn't know about that one because it was like in a weird spot in their reading. So.
Yeah. We did do that in the past.
Oh, cool.
But now we know there are 2 ways to do it.
Sorry, I didn't know you guys knew.
No, you're good. And then the lower bound was 0.110 for 7.
Mm-hmm.
And then 8 for the lower bound, you just do the p hat plus and minus the margin of error to get the upper and lower. 0.640 for the lower. And then for the upper, 0.860. And then as the TA said, for question 10, it decreases because we're increasing the sample size. Okay, question 11. I think this is where we officially are now, everyone. Okay. So if P is 0.5, what's the smallest n? So we use the equation NP is greater than or equal to 10, right? And then you just solve for n.
Yeah, and you do have to do both of them. So you do that one, and then you do the n or times 1 minus p hat is greater than or equal to 10.
And she said also the n times 1 minus p.
I did that.
Yeah. So I'm sorry, what did you guys get?
I got 20.
20. Awesome.
And then for 12, yeah,
1/10. So what you said? Plug it in. So it would be 1 minus 1 over 10. Then 10 divided by the answer. Whoops.
I'm like, yep.
1 minus 1 over 10. 10 divided by the answer. $11.11 or
What was it?
so it's 100. If you plug it in, you get 100 for the first equation. But for the second equation, I got 11.11. Is that just me?
Wait, what's the equation? It's 1 minus the second.
1 minus 1/10 is 0.9, and then you do 10 divided by that to get n, right?
So yeah, I got 11. So it's not 11.1.
And this one, I don't like the way it's worded very much because it says like the smallest one you can use. But when it says that, you do have to use the largest number to satisfy. So, because like if you, meaning like
100.
it should be 100 because like if you only had 11 or 12 subjects, then it wouldn't satisfy the other requirement. Does that make sense? It wouldn't satisfy the n times p is greater than or equal to 10. You need 100 people for that. So 100 is the smallest you can go. Does that make sense?
Let me try to tell my group members what you said.
Okay.
So she said the answer is 100 because that's the smallest you can have to satisfy both of them. Because if you only had 11.11, it wouldn't satisfy the first one.
Oh.
You know what I mean?
Yeah.
And it's
so
like
it
for sample
have to be
size.
100. Yeah.
Because then when you put you get 90, 90 is greater than.
Yeah. So yeah. Mm-hmm. Okay, we got it.
Cool.
Thanks.
Yeah.
It's like the Z, right?
So for 13, it's true because if you plug in 80 for n and 0.6 for p, you get greater than values every time than 10. Okay.
Mm-hmm.
So p hat is x over n, or wait, what did it say? 60%? Oh, that's the p. 38 over 80. .475. Am I behind? So to find the test statistic, it's just the z-score. That's what we're looking for.
And you can always plug this into the Excel sheet for the one proportion that you use for Unit 3. It's called the Categorical Data Analysis HAT. But when you plug it into yeah, I mean you don't have to. It just makes things like a little bit easier, and it's.
I know I got that, but isn't that p hat here and then what's t?
Okay, so the one proportion you said?
Oh.
Yeah. Because then you can type in.
Yeah, and so x would be 38 and n would be 80. Confidence 95. Null hypothesis 0.6, and then it is less than. So she said you can use the Excel file, categorical data analysis HAT, and then just plug in the info, and it'll give us all the answers.
Awesome.
So I got negative 2.282 according to the Excel file. Yeah, but what you guys did was just solve for z. Did you equal it all? Wait, what was the equation that you guys used?
I did the z equals p hat minus p over the standard.
Z equals p hat minus p divided by the square root of p times 1 minus p over n. Or yes. Standard deviation is that.
So I plugged in the and then so the p value is the p value from the Excel 0.01?
Yep.
Oh,
0.011. Because it's low, we reject the null hypothesis. So the fourth option? So Anna, can you tell us, just because I get a little confused, why it would be the fourth option, if that's correct?
Yeah, so as the fourth option, we have sufficient evidence to suggest, well, what's the fourth option?
Yeah, there's sufficient evidence to conclude that water quality in the area has decreased.
Yeah, so what you're trying to figure out with these tests is you're always trying to prove if the alternative hypothesis is true. And so when you reject the null, you're proving that the alternative hypothesis is true. Does that make sense?
When you reject the null, you prove that the alternative hypothesis is correct.
And no matter what your wording is, it's always going to deal with the alternative hypothesis. So you either have sufficient or insufficient evidence to suggest that that's true.
Deal with the alternative.
Yeah, I even wrote it down actually, like for my cheat sheet, I would write like reject the null and then what the wording's supposed to be. and then if we reject or fail to reject, and what the word is supposed to be. And that helped me.
Yeah, because whenever you reject, you say there is sufficient evidence.
Yeah,
And then whenever you fail to reject, there is insufficient evidence.
because you only care about the alternative.
And you're not
Right.
accepting the alternative.
Right. So weird. Why did I have to word it so funny?
I know. It took me all semester to get it.
Do you guys know what this
The what?
design study thing is?
Oh yeah, Anna, do you know anything about the final project? This design the study thing that we're supposed to
So
do?
it's just like a statistical project that you guys will do as a group. I'm
Just a
pretty sure
project
there's a
we do
rubric
together.
on it.
There is, and there's like each person we designate to do a task, but there's like multiple
Oh.
tasks, so we do like multiple things for each person because there's only 4 people in our group.
Yeah. I'm not even sure because I did mine. I actually took this class on campus.
Okay.
And so I'm not sure how that works. I would actually reach out to your instructor and see how she wants you to do it. Maybe she can post like an announcement about it because I don't know how she wants it done for online students.
Okay, that's okay. Okay. Perfect. That will be all then.
Okay, hey, thanks for letting me join you. I'm so sorry I didn't get the link.
Yep, you're good. Okay. Thanks a ton.
See ya.
Bye.